Okay, as far as skills go, we're not learning anything new today. We're just going to take what we know and now apply it to different ways questions could be asked you, or just different types of questions. Okay, so the first one here says, excuse me, the function f is defined by the rule f of x equals 2x squared over x minus 4. Find f prime of x and simplify. Okay, and obviously if it says simplify, you want to make it, you do have to do all the algebra. All right, so let's go from here. F prime of x is equal to bottom, x minus 4, times the derivative of the top, which is 4x, minus the top, 2x squared, times the derivative of the bottom, which is 1, all over bottom squared. Okay, up top, we're going to end up with 4x squared minus 16x minus 2x squared over x minus 4 quantity squared. And then we could combine like terms and get the final answer of 2x squared minus 16x over x minus 4 squared. All right, so that's just a basic quotient rule, finding a derivative. Part B says, determine the points at which the graph of the function has a horizontal tangent line. How do I find a horizontal tangent line? Not rhetorical. You guys did it for your homework 2 nights ago, 3 nights ago. Horizontal tangent line. Not a soul, huh?
Don't you have to plug in the points?
No, we have to find the points. Where, first of all, what is a horizontal tangent line? What does it mean when you have a horizontal line?
The slope is 0?
Yes, correct. The slope is 0. 99% of the time, you guys should be thinking slope so far in calculus. That's all we've talked about is slope. Okay, it's where the slope is 0. This is my slope function. So I have to set my slope function equal to 0 to find the points. Okay, but we do, when we have a rational expression, we do not set the denominator equal to 0, just the numerator. So we set the numerator equal to 0. How many points are we looking for now? You should know the answer to this from algebra. How many places is my slope going to be 0?
1.
Nope.
2.
2, because of this. It's a quadratic function, so we should have 2 places where the x-intercept is 0. Okay? All right, so we can solve this many different ways, right? There's quadratic formula, there's completing the square, and there's factoring, which is obviously the most common and easiest way. I'm going to factor out a 2x and be left with x minus 8. And now I set each factor equal to 0. 2x equals 0, so x equals 0. And x minus 8 equals 0, so x equals 8. Okay, it's not just asking for the x coordinates, though. It's asking for the points where the graph has horizontal tangents. So one place is when x is 0, I'm going to take that 0 and plug it back into my original. Okay, 2 times 0 squared is 0. 2 times 0 is 0. 0 minus 4 is negative 4, but 0 divided by negative 4 is 0. That's one point. The other point is when x is equal to 8. 8 squared is 64. 64 times 2 is 128. 8 minus 4 is 4. And 128 divided by 4 would be 32. So those are the 2 points where I have horizontal tangent line. Okay, if you have a calculator, if this is a calculator question, we're not even going to do this. we're going to go right to the calculator, and the calculator is going to do the work for us by finding those 2 points, the min and max of the, or min or max. They could be both mins. All right, number 2, okay? It's going to look different. You're going to ask yourself, well, how can I find p prime of -2 if I don't even know what the function p is? We do not need to know the function if we have a graph, okay? There are 3 ways that math can be presented to you, okay? And that is algebraically, okay, graphically, and numerically, okay? This is graphically, okay? Algebraically would be the function itself, and numerically would be a table. But always remember that all a table is a bunch of numbers that make that graph, and so on, okay? So we know that p of x is equal to f of x times g of x, okay? And we have the function f of x, and we have the function g of x, and we know q of x is equal to f of x divided by g of x. We're asked to find p prime and a q prime of a very specific value. So the first thing I'm going to do is I'm going to find the derivative of p, okay? P is f of x times g of x. Well, we know the product rule is f of x, g prime of x, plus g of x, f prime of x, or first thing times derivative of second, plus second thing times derivative of first. Once I know this, and I have a graph, I can now find this. Okay, p prime of -2 is equal to, I'm going to write it out this first time, but you eventually will probably not write this all out, and you'll just go right to your graph. But it's going to be plug -2 into all my x's. So it's f of -2, g prime of -2, plus g of -2, f prime of -2. Keep in mind, we have the graph of f and g. We do not have the graph of f prime and g prime, but we'll be able to find those values. Okay, we'll start with f of -2, okay? F is this one right here. F of -2, you got dots on your graph. We can barely see them, but here's -2, right? So f of -2 is this one right here, okay? And that is a 3, correct? Everybody agree with that? That would be 3 right there?
Yeah.
All right. Next one, okay, we just got to do a little thinking. G prime of -2. Well, first of all, let's go to G of -2, okay, which is right here, okay? That's G of -2. I want G prime of -2. So how am I going to figure that out? What's prime mean?
The derivative of the
The
point?
derivative. The derivative. And what does derivative mean?
Slope.
Slope. So I want the slope of this line. G prime of -2 is the slope of this line. Understand, again, when you're asked to do these things without knowing a function, you're going to be given lines, okay? You're not going to be given a curve, okay? Because we couldn't find the slope of a curve if we didn't know the function, unless it was told to us. So the slope of this appears to be down 1, right 1, so -1. So G prime of -2 is -1. G of -2 is this point, okay? So you got to, what you got to say to yourself, by the way, is, am I being asked for a point, or am I being asked for a slope? This one's asking for a point, this one's asking for a slope. This one's asking for a point, this one's asking for a slope. The point here is 0 times f of -2. Now, it's not going to matter what f of -2 is, because 0 times whatever you get is going to be 0, but we're going to go find it anyway. F of -2 is the slope of this line, because this is f at -2. And the slope of that line looks like it's down 1, right 2, so that'd be down -1/2. But the bottom line is that becomes 0, and 3 times -1 is -3. So p prime of -2 is -3. The whole point of this is to show you that you do not need to know an actual function if you have a graph or if you have a table. Okay, you only need one of the three to be able to figure out some values. And we got to be able to take the derivative like this, not just when it's an actual function, like so up in number 1. All right, let's go on to B. We are asked to find Q prime of 0, so we first have to find Q prime of X. Okay, this is a quotient rule, so it's bottom G of X times derivative of top F prime of X minus top F of X times derivative of bottom G prime of X all over bottom squared. And now we're asked to find Q prime of 0. Okay, which means Q prime of X is this, Q prime of 0 is G of 0, F prime of 0, minus F of 0, G prime of 0, over G of 0 squared. And this is kind of stinky when you get to the end, but okay. G of 0 is 0. It's this point right here. Times F prime of 0. That is the slope of this line. This is F of 0. The slope of this line we determined in the last problem to be negative 1/2 minus F of 0. F of 0 is 2, 1, 2. G prime of 0 is the slope of this line. That looks to be 1, up 1 over 1. And that whole thing is over G of 0 squared, and G of 0 is 0. And that's why this problem kind of stinks, because in the end, the answer to this is undefined. Okay, because we have 0 in our denominator. But I just want you to be able to find the values, okay? All right, any questions so far?
Wait, how is f of 0 equal to -2?
F of 0 equal to what?
-2.
It's not equal to -2, it's equal to 2, but there's a minus in front of this, right? Because it's minus this whole part. It's equal to +2. Does that make sense?
Yeah.
Okay. All right. All right, so this is almost like number 3 here is like getting a table, but you're just getting specific values in a table, okay? We have F of 4, we have F prime of 4, G of 4, and G prime of 4. And we're given different functions throughout, okay? So A is H of X equals this. We are asked to find up here in the directions H prime of 4, okay? So before we find H prime of 4, we got to find H prime of X. Okay. Okay. Just because you got product and quotient rule on the brain doesn't mean we're going to stick with product and quotient rule. Okay. This is 4f of x. The derivative of 4f of x is 4f prime of x. The derivative of f of x is f prime of x. The derivative of g of x is g prime of x. Now I'm going to plug in and find h prime of 4. So it's going to be 4f prime of 4 minus g prime of 4. And now we just go to our table or list of values and find our numbers. So f prime of 4 is 2. So I'm going to have 4 times 2 minus g prime of 4 is 1/4. And then I have 8 minus 1/4. Okay, and this is 32/4. right? 8 is 32/4, and 32/4 minus 1/4 is 31/4. All right, B, h prime of x is equal to, okay, we got a product rule. So it's f of x, g prime of x, plus g of x, g prime of x. We're asked to find h prime of 4. I'm not going to write out all the 4s in there this time, okay? We're just going to go right
Mr.
to it.
Masson,
Yeah,
wouldn't it be
yeah, that's an F. I got you.
okay.
Beat you to it. You're like a hawk in there. All right, f of 4, let's just go right to it, is -1. G prime of 4 is 1/4. G of 4 is -3. And f prime of 4 is 2. And then it's algebra from there. So it's just -1/4 minus 6. That's going to give you -25/4. All right, I'm going to go ahead and skip C and D. You guys get the idea. Okay. It's just doing the same thing that we did on the other side, but I want to make sure we get to some of these application problems because obviously the application stuff is going to be the most important in the end. Questions on either A or B there? All right, number 4. The base of a triangle is given by 3t plus 1. So we got a triangle. The base is 3t plus 1. The height of the triangle is 2 radical t, where t is time in seconds and the dimensions are in inches. Find the rate of change of the area with respect to time. What does rate of change mean?
Slope.
Slope. What does slope mean?
Derivative.
Derivative. Okay. So I got to find the derivative of area with respect to time. What's the area of a triangle?
1/2 base times height.
1/2 base, which is 2 radical t, times height, which is 3t plus 1.
Mr. Masson,
Yeah.
isn't 3t plus 1 the base?
Yeah. Oh, I just said it backwards, but we're so good on our formula. You're right. Okay. 1/2
Okay.
height times base. Same thing.
I wasn't
Sorry.
sure if that would mess it up or anything.
No, yeah, you're good.
All
Yeah,
right.
same thing. Base times height, height times base. All right, so I'm going to just go ahead and distribute this into this, right? This 1/2 and this 2 will make it a radical t times 3t plus 1. And then it's derivative from there, okay? And we did one just like this in the homework last night. What number was that? Was that 17, right? Can't remember which one it was. So the derivative is first thing times the derivative of the second thing. Derivative of 3t plus 1 is 3. Plus second thing, 3t plus 1 times the derivative of the first thing, which is 1/2 radical t. And then from there, it's going to be some algebra manipulation, just like on number 17. I think it was 17. I keep saying that. It wasn't 17. It was
It was number 3.
3. It was number 3. I knew I did it for you guys. It was number 3. Okay. But same concept. Okay. You just got to find a common denominator. And again, most likely they're going to say, okay, now find the rate of change of the area when t is 3. Okay. And so whatever, let's just say t is 4. So you're just going to plug a 4 in. Okay. So we're not going to focus too much on that algebra manipulation, but you might have to do that. Okay. All right. So you are going to see a problem just like that in your homework tonight. Okay. All right, just as you can obtain, okay, so we're gonna take that that position in that velocity one step further now. Just as you can obtain a velocity function by differentiating a position function, right? Velocity is the derivative of position. You can obtain an acceleration function by differentiating velocity. Okay, and so this is listed here, okay? Velocity is the derivative of position, acceleration is the derivative of velocity, or acceleration is, and it's going to say this, that's this fill in the blank down here at the very bottom. Oh, I skipped this fill in the blank, didn't I? Another way of looking at this is that you can acceleration by differentiating position twice. Okay. And acceleration is also called the second derivative of position. And second derivative is denoted by two little tick marks up there. Okay, so you have position S of t, you have velocity, which is S prime of t, and the way we say acceleration would be, anybody want to take a guess? S prime of t, and then what?
S2 prime of t?
Pretty good guess. We just say double prime. And then triple prime, and then after that, we don't say anything. Okay, so it'd be, we just say S double prime. 2 prime, that'll work, okay? But S double prime is how we would say this, or acceleration is the second derivative of position. Okay, 2 tick marks. And then over here, all right, flipping that over, there's just a bunch of different ways going all the way up to 4, okay? Second derivative is a higher order derivative. You can define derivatives of any positive integer order. For instance, the third derivative is the derivative of the second. Okay, the fourth derivative is the derivative of the third. And these are our notations, okay? Y prime, Y double prime, Y triple prime. Once we get to past Y triple prime, we just put the number of derivatives we're taking. So we would just put a 4, and then a 5, and then a 6, and so on, okay? We just put N, okay? Or F prime, F double prime, F triple prime, F4. And then these are your other notations that go along with those. So dy dx, d squared y dx squared, d cubed y dx cubed, and so on, okay? But those are just the notations. First derivative, second derivative, third derivative, fourth derivative, and so on. All right, a couple more word problems, and then we'll get you out of here. Okay, because the moon has no atmosphere, a falling object on the moon encounters no air resistance. In 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon. The position function for each of these falling objects is, there's your position function, where S of t is the height in meters and t is your time in seconds. And it's graphed to the right over here. That's our position function, okay? What is the ratio of Earth's gravitational force to the moon? Okay, to find the acceleration, we differentiate position twice, okay? So the ratio of the Earth's gravitational force is the acceleration, okay? The derivative of negative 0.81 t squared plus 2 is 2 times negative 0.81, which is negative 1.62. Subtract 2, I said t, scratch that, negative 1.62, and then t, subtract 1 to the first. That is our first derivative. And remember, this also represents phi of t, right? Second derivative, so it's the derivative of this, okay, not the second derivative of this, but now we're taking s double prime, is negative 1.62 t to the 0, or just that, okay? And this is v prime of t, or a of t, or s double prime of t, okay? Acceleration is the derivative of velocity. Velocity is the derivative of position, or acceleration is the second derivative. So the acceleration due to gravity on the moon it's this constant function now, negative 1.62 meters. Now, don't not miss this or go ahead and catch this. It's meters per second, okay? Velocity would be negative 1.62 t meters per second. And now acceleration is per second. All right, because the acceleration due to gravity on Earth is negative 9.8 meters per second, the ratio of the Earth's gravitational force to the moon it's the Earth's gravitational force negative 9.8 over the moon's, which is negative 1.62, and we divide that out and we get approximately 6.0. Not sure exactly what it is. I'm going to go ahead and type that in really quick just to get that. I want to see what that decimal is. Yeah, I don't like that answer. We're going to go with 6.049 because I want you to round to 3 decimals. Okay. Questions? All right, you're starting to see questions like this are going to be like questions that will start, they're going to start being like FRQ type things, okay? Where they're asking you something and then based on that, you're going to find something else or whatever you're given, okay? A particle moves in a straight line so that at time t, where t is greater than or equal to 0, its position is given by this function. So we have a position function, okay? First question asks us, what is the average velocity in the interval 0 to 1? As soon as you see that word, you need to think slope of a secant line, which is just the slope between 2 points, okay? So we have to find S of 0. Okay, I'm not going to bother you with the math, but the math is actually easy on this one. It's 1. And we have to find S of 1, okay? It means plugging 1 into our position function. And when we do that, I'm just going to tell you get negative 6. So you have the 2 points, 0, 1, and 1, negative 6. And now you're just going to find your slope, okay? So this is equal to negative 6 minus 1 over 1 minus 0, or negative 7. Key is recognizing phrases, right? Average velocity. Part B, instantaneous velocity. What is that? Quick. Quicker.
Isn't it the absolute value of average velocity?
No, that's the speed. Instantaneous velocity. You see this word right here, instantaneous. You say to yourself,
0.
no.
Slope.
Slope or
Yeah,
derivative. Slope or
don't you-
derivative is correct, okay? So you see instantaneous velocity, and it's the slope of the tangent line at 1. So the first thing we have to find is S prime of t, or V of t. We're finding instantaneous velocity at a specific moment. And the derivative is 3t squared minus 6t minus 5. Derivative of our position function. We are asked to find the instantaneous velocity at time 1. So we need to find V of 1. So that's 3 times 1 squared minus 6 times 1 minus 5. Which is what, negative 8? And in this case, they did not give us units, right? Okay. Let's just say it was feet per second, right? So the velocity would be, I say feet per second. If the units were feet and seconds, it'd be feet per second. Okay, average velocity is just going to be negative 7 feet. Okay, this is feet per second. And now acceleration is either the second derivative of position or the derivative of velocity. okay, which is this one. I'm just going to write a of t, that's acceleration, and I'm going to take the derivative of this function right here. And the derivative of 3t squared minus 6t minus 5 is 6t minus 6. We are asked to find the acceleration at time 1. So that's a of 1, which is 6 times 1 minus 6, which is 0. So at time 1, our acceleration is 0. Doesn't mean we're not moving, right? Just means we're not accelerating. All right, the last thing is just doing some higher order derivatives, okay? Meaning second derivative, third derivative, fourth derivative, whatever, okay? And by the way, you keep taking a derivative of a function until you get to what? Like if it says find all of the derivatives, you keep going until you get to what? What's the last thing you could take the derivative of?
A constant.
A constant, right? So once you get to 5, then the derivative of 5 would be 0. You can't take the derivative of 0. So once you get to that, you'd be done, okay? All right, let's just look at a few of these real quick, just one or two of these, okay? So we're given f of x is this. We're asked to find f triple prime, okay? So f prime is, the derivative of this is 20x to the 4th minus 3x squared plus 12x. That's our first derivative. We got to go all the way to 3. F double prime is, do it again, 80x cubed minus 6x plus 12. And f triple prime is 240x squared minus 6. And we could actually do that 3 more times, okay? We could take the derivative of that and get 480x. We could take the derivative of that and get 480, and then we could take the derivative of that and get 0. All right, we'll do B and then we'll call it a day. We don't need to, these are just doing memorized ones, okay? It asks us to find the 4th. We're given g of t. So g prime of t. What's the derivative of sine?
Cosine.
Cosine. What's the derivative of cosine?
Negative sine.
Negative sine. All right, let's get fancy here. What's the derivative of negative sine?
Negative cosine.
Negative cosine. All right, no 4 tick marks, just put a 4. Like kind of like as an exponent, but it's not. What's the derivative of negative cosine?
Sine.
Okay, it just goes back to it eventually, right?
Ye.
So a polynomial function, like the one in 6a, there's a definite number of derivatives we can take, okay? We can only take 3 more derivatives on 6a, and then we're done. But on 6b, how many derivatives can I take?
Infinitive.
An infinite number of derivatives. We can keep going on that, okay? So they don't all always have an end, but polynomials definitely have an end. All right, any questions? We were pretty long today, so I'll just, if you have any questions on your quiz, I'll go over those tomorrow. I think we'll be a little shorter, Marvin. We'll have to check. But I posted the homework this morning. Again, it's out of the book, but I posted the book pages, and it's on there as assignment number 19. I just want to let you know, if you haven't noticed, I did flip. I'm pretty sure I did it in this class already. But I flipped the way Canvas is showing you stuff. So now instead of scrolling down, I flipped it. So now the most recent thing is on the top. Okay, I hope that's better for you. If not, sorry, but I kind of like it better that way instead of me having to scroll all the way down to the bottom all the time. So it's actually going in reverse order, but it's always by day. So you can just find the day and pick up on that. Okay. Any questions? All right, if you have anything in private, stick around. If not, you guys have a great day.
Have a good day, sir.
You too.